Hello, I'm Richard Hansen, owner of Georgia Water Tanks. We provided the pump systems and control valves, etc. for the Pearl project. I'm here to conduct some training on the operation of these various skids, how they work to provide rainwater or reuse water for the Pearl project. Starting with on the drawing here, this drawing is currently in the mechanical room or the treatment room with both the NPW pumping skid and the treatment skid, and I found it to be a valuable guide for understanding how water flows through the various parts of this. Starting here on the left with rainwater coming from the roof either directly to the underground cistern or through this above ground cistern. Eventually the water all goes here. This level is monitored on the treatment skid over here. If you go to tank, this shows you the level of that cistern. And these valve 1, valve 2 control how we bring water in there and how we use the reuse water. Valve 1 is this one here. When there's available space in the cistern for more rainwater, this valve opens and this stored rainwater flows by gravity down here. When this level gets too low, then we actuate this valve here, which allows reuse water from the city to flow through our treatment and to the day tanks. That water, before it comes to us, here's the valve I was just pointing at in person. Before it gets to this treatment skid, it goes through a water softener and another sediment filter. So that's city reclaimed water getting further treatment before it goes through the UV. The water then flows up to the day tanks that are outside. It's using, the pumps are actually controlled based on pressure. There's a pressure transducer here, which you can see right there. So, because we're filling two different day tanks, we don't look at the day tank levels to start this pump. We look at pressure here. These two control panels actually open valves back here, and over here there's a float valve for the irrigation one. That valve, when this tank needs water, this controller, that's this controller right here, opens this valve, the pressure drops, the pressure sensor here detects that, and the pumps come on. And this valve is currently out this door and right up there. So, valve opens, pressure drops, pumps come on, water flows through the treatment, fills the day tank. When it fills the day tank, this sensor detects that. This controller, which is this one here, closes the valve, pressure rises, pump shuts off. So now we have water in our NPW day tank, which is situated. Building pumps. This is the NPW pump. It looks like a regular domestic water booster because it pretty much is. It works based on drop in discharge pressure. Right now we have 93 psi on the discharge side. The only difference is this tank control, which is used for other things too, but it works great for rainwater harvesting. So right now this tank level set at open at 20% and close at 30%. Eventually we'll have it closing at 90 or 95%, and we can start it lower than that or higher. It doesn't really matter. This is the standard screen for these domestic water boosters. You've got a different icon for each pump. This shows that pump number 3 is in lead. They're all at 0 hertz, which means they're not. Here's our Texas-sized irrigation day tank. Rather than a level sensor on this one, we have a pressure transducer that's doing double duty. 0.4 feet, which means it's got about 4 feet. Here's the control panel for it. Just turned it on so it's starting up. We have 2 submersible pumps, as you saw in the drawing earlier. We're showing 1 or 2% of tank filled, which looks about right. Started 1 pump. That's the green there. These pumps only need about 3 inches of cover in order to work. They're really great for fully utilizing these tanks. So you see the pump has gone up to 66 psi. Over the set point, it's starting its low flow shutdown. We do have an actuated valve to bring in the reuse water for this one. So it's detecting flow occasionally. This has not been connected to the irrigation system yet, so I'm not sure where any water is going, and I'm not going to leave this on for long, just in case there's a leak. We've got a level switch in each day tank for each pump system that is actually controlling the pump on and off. When that float goes down, then it shuts off the pumps. After we go through, well, let's cover our treatment. Covered how this water flows, but the treatment skid, you can see it's got both the reclaimed water connection and the pumped rainwater. So there's that pressure sensor. Then there's a check valve that prevents reclaimed water from interfering with that pressure sensor reading. Then we've got sediment filter and UV, and we have 2 of them. So we have 40 GPM per branch here and full redundancy. After we go through those 2, after the water goes through those 2, it's almost drinkable. But for additional control, we've got these 2 tanks here, which go through tubing over to this unit here. We call it the Chemtrol. It's the brand name. What it does is it monitors both pH. We've got soda ash here, and we've got chlorine in a liquid form over here on the left. It's monitoring those and injecting more to get to a certain point. pH should be at about 7.5. I'm hoping we can tune this a little bit more because it tends to overshoot, as you can see here. And then the chlorine level should be about 1 part per million. We also have a problem with this flow meter right here. It's not giving us good data, so it's hard to get good readings for particularly the ppm meter. So all that goes on. Oh, and this copper pipe here, this is the discharge from that unit. And it goes over to there, and it connects to the stormwater piping, so that water goes back to the system.